Alright, today we're going to look at completing the square. So let's start off with looking at this problem. Now typically we would move the 81 over to the other side. But here, if we notice that x squared plus 20x plus 100 is a perfect square trinomial. So we can factor just the left-hand side. Now this looks like the problems we've been working on for the last couple of days. We've isolated the factors. So we can take the square root of both sides. So we end up with x plus 10 equals plus or minus plus or minus 9, which is the square root of 81. Move the 10 over, separate into two separate expressions. So my two answers are -1 and -19. We're going to use this process today when we complete the square. So the last two steps of our equation are going to look just like this. So first of all, we need to talk about what does it mean to complete the square. This is a trinomial, perfect square trinomial. It's when you have the same factor twice. So look at the relationship between b and c. You can always find the c term, the 16, by taking half of b and squaring it. So half of -8 is 4. 4 squared is positive 16. This relationship exists in all perfect square trinomials. So make sure you remember that formula. C is equal to half of b squared. Let's practice this first, because this is the basics for all of completing the square. So first of all, we start off with x squared plus 10x. Let's find c. Let's make this into a perfect square trinomial. So half of 10 divided by half of 10 is 5. 5 squared is 25. So c is equal to 25. Now we can factor that trinomial into x plus 5 squared. Look at number 2. b is -12. Half of -12 is -6. -6 squared is 36. We can factor the trinomial into x minus 6 squared. And finally, let's look at 3. Notice that b is an odd number. We can still do that even if we can't divide by 2. So half of -5 is -5 halves. When squared, that's 25 fourths. So c is equal to 25 fourths. So when we factor this, it's going to be x minus 5 halves squared. Okay, so we're going to be using this technique to solve quadratic equations that can't be factored. All right, let's look at our first one. So here's our question. Now, the rule to this, let's go back up and look just at the words. You must keep your equations balanced. So whatever you add to one side of the equation, you have to add to the other side of the equation. So we can't get our equations unbalanced. All right, back to our problem. The first thing we want to do is isolate those x terms. So we want to move the 4. So that's always step 1. Get the x terms by itself. Now we're going to complete the square. So we need to find c. So c is half of -12 squared, so which is -6 squared, which is 36. Notice I've added 36 to both sides. We have to keep the equation balanced. Now we're going to factor the trinomial. So x minus 6 squared equals to 32. Now we're back to the problems we've been working on for the last couple of days. Take the square root of both sides, simplify the radical, and then move the 6. So our final answer is x is equal to 6 plus or minus 4 square root of 2. We would have gotten the same answer if we had used the quadratic formula. This is another alternative to the quadratic formula. All right, notice that our lead coefficient is 1. We can only complete the square if our lead coefficient is 1. So let's find out what to do if we don't have a lead coefficient of 1. All right, let's start off with our original question. Here's our problem. All right, so it says leading coefficient is not 1. So same way, we're going to move the 14. All right, because the lead coefficient is not 1, we're going to have to factor out that 2. So that's what this step is. All right, so here's what I had. This was my original. Alright, let's complete the square. Half of 4 is 2. 2 squared is 4. So we're going to add 4. Oh, hold on. I erased it. Okay, let's see. We're going to add 4 to complete the square. Now think about, be careful here, because actually what have I added to this side on the left-hand side of my equation? I got 4 times 2, so that means I need to add 8 on the other side of this equation. That's one of the common mistakes that people make. They want to put a 4 over here instead of an 8. But if you factor something out, you've got to remember to multiply it back to add that 8. Alright, now we're going to factor the trinomial. Divide by 2. Take the square root of both sides. So the square root of negative 3 is I square root of 3. And then move the 2. So my final answer is x is equal to negative 2 plus or minus I square root of 3. It's all about learning the process. Alright, here's some practice problems. Process is going to stay the same each time, just numbers are going to change. So, look at our first example. Move the 19. What's in pink is where I completed the square. Factor the left side, factor the trinomial. Take the square root of both sides and separate. Move the negative 10 and separate. So my two answers are x equals negative 1 and x equals negative 19. So this would have factored because I'm ending up with integer or rational roots. This means this thing would have factored. But here again, completing the square got me there too. If anytime you need more time, just pause the video. Alright, another example. In this one, notice we have a lead coefficient. But 3, 36, and 150 all have 3 as a common factor. So what I did first was divide everybody by 3. Move the 50. Complete the squares in in pink. So half of negative 12 is 6. Negative 6 squared is 36. So I added 36 to both sides. Factor the trinomial. Take the square root of both sides. And move the negative 6. There's my final answer. Alright, let's look at one where I can't get rid of my lead coefficient. So like this problem. Not everything is divisible by 2. So let's move the 5. Factor out the negative 2. Now what's in pink is where I completed the square. Half of negative 2 is negative 1 squared is 1. Now be careful, negative 2 times 1 is negative 2. That's why I'm adding a negative 2 on this side. Factor the trinomial. Divide by negative 2. Take the square root of both sides. Now, ignore the square root of 2 over 2 for a moment. That's what you get when you take the square root of both sides, but we're not allowed to leave a radical in the denominator, so what's in purple is where I rationalized. Move the 1, and there's my final answer. Now, either form of this is okay. The second form over here is probably the best because it's in standard form. So the real part and then the I. Just make sure the I is outside from the radical. Alright, one application of this. Oh, got one more left. Let's look at one where our b is an odd number. Okay, so let's start from the beginning. Here's your original. Move the 1. What's in pink is where I completed the square. So half of 5 squared is 25 fifths. So add 25 fourths. Add 25 fourths to both sides. Factor the trinomial. Take the square root of both sides. And then move the 5 halves. So this is our irrational answer. It's not imaginary, it's irrational. Alright, now let's look at where application of this. Find the vertex using completing the square. In other words, change from standard form into vertex form. Now recall, there's vertex form. Alright, we treat this a lot. We do pretty much the same steps, but this time we have a y that we have to keep. We can't throw that away. We don't have a 0 anymore. So instead of moving the 22 to the 0 side, I'm just going to move it to the y side. Alright, so I'm going to subtract 22, complete the square. So half of negative 10 is negative 5 squared is 25. So I've added 25 to both sides. Factor the trinomial. And now all I have to do is move the 3. So now we're in vertex form. And in vertex form, our vertex is hk. So now it's very easy to get our vertex. We don't need to use the opposite of b over 2a. It's as much, I don't know, I think it's probably fewer steps to change it into vertex form. A couple more examples. Alright, here's our original. Move the 1 to go with the y. Because we have a lead coefficient with our x squared, we need to factor out a negative 2. Alright, what's in pink is where I completed the square. So half of 2 is 1, squared is 1. But because I factored out a lead coefficient, I've got to multiply negative 2 times 1 and get negative 2. Factor the trinomial. Move the 3. Now it's in vertex form. So our vertex is negative 1, 3. Alright, one more example. Let's look at one where we have the lead coefficient as a fraction. Alright, same process. Move the 1 to go with the y. Because I have a lead coefficient of 1/2, you have to factor out a 1/2. So 10 divided by 1/2 is 20. Now complete the square. Half of 20 is 10, squared is 100. But remember, we factored out a 1/2, so we actually 1/2 times 100 is worth 50. So add 50 to the other side. Factor the trinomial and move the 51. So now we're in vertex form. So our vertex is negative 10, negative 51. Alright, that's completing the square.